Welcome back to 3 Inquisitive Kids. In this video, we will be looking at probability. First, let's define what is probability. Probability is basically the likelihood of something happening. For example, what is the likelihood of a spinner spinning on a red section, or the probability of you winning the lottery? These are all probabilities, and some are even things that we talk about in our everyday lives. So let's first look at the formula for probability. And you really don't have to memorize a formula for probability because once you logically really understand what probability is, you really don't need to memorize a formula in order to solve probability problems. So the probability formula is total number of desired outcomes out of the total number of possible outcomes. The probability of something happening is the different types of outcomes that would happen out of the total number of ways that it could turn out, desired or undesired. So in order to understand further what I mean, let's look at some examples. Identify the number of desired outcomes and total number of possible outcomes in the following problems. How many possible outcomes are there for a fair coin to be flipped 3 times, with all 3 times ending in tails? So let's first find our total number of possible outcomes. How many different outcomes are possible for flipping a fair coin 3 times? Well, lots of the times when we have problems like flipping a coin, I like to draw out a tree. So H for heads and T for tails. Say on the first try, we got H and T. So this is what we got on our first try. Now, after getting that possibility for the first try, we roll it 2 more times. And this time, we still have 2 more options. We could roll another H or another T. So this would be what we could get for our second roll. And for the third time we roll it, we can draw more branches of this tree, and each possibility can either have another H or another T. So this just shows us all the different possibilities that can be rolled when rolling a fair coin 3 times. So let's count the number of different outcomes. 1, 2, 3, 4, 5, 6, 7, 8. So the denominator would be 8. The number of possible outcomes is 8. But how many desired outcomes are there? Remember, what we are looking for here is all 3 times ending in tails. So let's go over each of these outcomes and see which ones end in tails. Which ones have all 3 ending in tails? Well, we have HHH, that does not work. HHT, HTH, HTT, THH, THT, TTH, and TTT. So as you can see, there is only one outcome that has all of these flips ending in tails. So our numerator would be 1, since there is only one desired outcome possible. So our probability for this would be 1/8. Now let's take a look at our second problem. Amanda has a jar filled with pieces of paper, and each piece of paper has a number from 1 to 100 written on it. What is the chance that the number chosen from the jar is a multiple of 8? Remember, the range of these numbers is from 1 to 100. So what would be our denominator? Well, since there are many pieces of paper written from 1 to 100, there are 100 total numbers that could be chosen. So our denominator, or the total number of possible outcomes for this problem, is 100. On the top, we can look at our desired outcomes. We're looking for multiples of 8. So in the range from 1 to 100, how many are multiples of 8? Well, we could do this by just taking 100 and dividing it by 8. And you'll see that the closest multiple of 8 to 100 that is not exceeding 100 is 96, which gives us 4. So we know that there are 12 multiples of 8 in 100. So that would be our numerator. But here, since we have a fraction, and usually we express probabilities in fractions because it's easier to evaluate, we can simplify it to get 3 over 25. So our probability for the second problem is 3 over 25. Now that you have a basic understanding of how to identify probabilities of simple word problems, stay tuned for the next video where we will be looking at some probability word problems. Thank you so much for watching through Inquisitive Kids. We'll see you next time.